Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Maths compound interest. So last time we were talking about maths, we were talking about simple interest, whereby we are adding the percentage interest on the original amount. So if you haven't watched that video, make sure you do, because that sort of explains the basics of interest and how it all works. And I will include the link to that video in the description below, so don't worry. And today we'll be talking about the second of the two interest types. We'll be talking about the compound interest. And this interest is slightly more complex to understand, but also in real life, meaning this interest is actually tends to be more powerful than the simple interest. So, without further ado, let's get started. So, what is compound interest? Compound interest is the interest that grows based on the previous amount. So it doesn't grow from the original amount like simple interest, it grows from the previous amount. So that works slightly differently. So here I included an example. The rate is 10%, the interest rate is 10% per year, and we are starting with £100. So we have £100, 10% of that is £10, so we add that on. So £100 plus 10% is £110 after 1 year. But then, for the next year, to calculate the amount after 2 years, we are adding on 10% still, but we are adding on 10% on £110. We are not adding the 10% on the original amount. We are adding 10% on the current amount of £110. So now 10% of 110 is actually 11. And therefore, if we add on that 10%, we get £121 rather than 120, which we would with a simple interest. So this is how compound interest works in its most basic form possible. And here it may not look like much of a difference, but if we were to stretch that over, say, 15 years, the difference would actually be quite substantial, because compound interest grows, because it's the more money you have on the said account, the more in the absolute terms you are getting from that interest. So as the time goes on, so does the absolute interest. The percentage interest stays the same, but the absolute interest grows because of the growing amount, like demonstrated here. Now, the most important thing to consider here is that the single most important thing is this formula and how to use it. This formula shows us how to calculate things to do with compound interest, how to calculate compound growth or even compound decay, which I will go into in a sec. And this formula is so useful. Trust me guys, it is so useful. Make sure you remember this, because calculating compound interest can be painful if you don't know this formula. Because say if you looked at this example and you wanted to find what happens, what's the amount of money after 15 years? Well, in this case, what you would have to do is you would have to keep doing this, adding on that 10% 15 times, which in exam would take you a ridiculous amount of time, and it's just not worth it. Whereas if you know that formula, you'll be able to quickly calculate the compound growth or the compound decay. You will be able to calculate everything about the compound interest with this formula. So, what is the said magical formula? Well, here it is. N is equal to n0 times multiplier to the power of n. So what does this signify? Well, this n here signifies the final amount. What do we get at the end? So it would be that £121 here. So that's what we get at the end. The n0, on the other hand, signifies the initial amount, which is what we are starting with. So in this example, that will be £100. So this is the initial amount, what we're starting with. Now, the interesting one here is the multiplier, which is the rate, which essentially shows us the rate, the percentage rate. However, here we are not expressing this as a percentage. We are expressing this as a decimal, as a total multiplier. So for example, 5% increase, for 5% increase every year, for example, we would include 1.05 rather than 5. Because we are saying this in an absolute multiplier form, in the decimal multiplier form. So 1.05. Here, when we have 10% rate, we would say 1.10. You get the gist. 35%, 1.35. But we can also use this formula to calculate the decay, the depreciation, where we are going down in a compound fashion rather than going up. So for example, say a car. When we buy a new car, it's worth a lot of money, but the older it gets, it depreciates by a certain amount of percent every year. So say, for example, a car depreciates 5% every year. So every year it's 5% cheaper than it was last year. So here, if we wanted to calculate that, we would use a multiplier of 0.95. 5% depreciation. So 100 minus 5 is 95. So 0.95. So that's how we use this part. That's how we use the multiplier part. And that's where a lot of people make a mistake, which is why I'm spending so much time on this and making this clear. And we have here the final component of this equation, which is number of increases. That's what I call it. And that signifies basically if we have a compound interest rate per year, number of increases. So here we would do 2 years. The number of times we are doing this, number of times we are compounding this. Whether it be years or whether we are doing days or months, depends on the rate. How often we want to compound this. That will give us the total number of increases. So if we have a rate of 10% per year and we want to find out what's happening after 15 years, we would put 15 as this part here, because we are doing 15 years, so 15 times we will be compounding that whole thing. So that's how the formula works. And now the important thing here is that you can rearrange this as any other formula. You can rearrange this as long as you stick to algebra, your basic algebra, your basics of transposing formulae. You can find any value here. You can find the initial amount or multiplier. You can find anything you want from this formula as long as it comes to compound interest. And that's why this formula is so powerful and so much. It has so much of a use these days, every day. In banking world, it's just so useful. So here's an example. So I will just quickly show you how this works. So the question is, £180 is invested at 3% per year in a compound interest fashion. How much money will that give us after 11 years? So now if we did that, you can see how quickly we would have a problem. We would just run out of space and probably time. So here we are going to apply this compound interest formula. And it's going to work very simply. So sticking to this formula, n, which is the final amount, is equal to initial amount of £180, which is multiplied by, we are increasing, the rate is 3%. So going with our multiplier, of the percentage multiplier, our multiplier will actually be 1.03, because it's 3%, 1.03. So that's our multiplier. And therefore, our number of increases, how much is that? Well, the rate is 3% per year. And after 11 years, we'll be compounding this 11 times. So the number of increases is quite simply 11. So now you throw that in your calculator and your actual final value should look somewhat like this. So the final amount is £249.11. So that's how quickly we worked out this question. So, and here actually you can see how this added up. So we put in £180, and after 11 years we get this, despite only doing 3% each time. So you can see how this works, and compounding is actually incredibly powerful when it comes to even investing. It is such a powerful technique, and that's why it's so exciting in maths. So this is it for today, guys. This is how compound interest works. Thank you very much for watching my videos. I really appreciate when you guys watch my videos. If you want to stay up to date on GCSE maths and biology, chemistry and physics videos, hit the subscribe button below. Don't be shy. If you want to have any questions, if you have any questions to me, please shoot that in the comments, pop it down in the comments. I will try to get back to you as quickly as possible. Thank you again for watching, and see you next time.